Hi, and welcome to The Click. Today, we're going to be covering inequalities, what they are, and how to resolve them. Let's go. So, what is an inequality function? So, we know from our regular functions, one-step, two-step, multi-step linear equations, that they all used an equal sign to equate two different expressions. Sorry about that. That they used an equal sign over here to equate two different expressions. However, the inequalities that we'll be looking at today are a bit different. Instead of equating two expressions, they'll actually be comparing their value sizes using these specific symbols. Now, before we move on to illustrating these on a number line, which we will learn how to do today, let's just briefly go over what each symbol means. Now, first, let's just go through our greater and greater than equal to symbols. When we're discussing when a number is greater than or greater than equal to, we can see that the number on the left-hand side is greater than the number on the right-hand side. Or for the case of greater than equal to symbol, we can see that it's at least greater, the number on the left is at least greater than the number on the right-hand side, though that may not always be the case. So let's take the example of 2 is greater than 1. Now, this inequality does match because we do know that 2 is greater than 1, hence this symbol is appropriate. We wouldn't be able to say 2 is less than 1 because that is not factually correct. We can also use this symbol for this case. However, it doesn't really make much sense to use it for 2 is greater than equal to 1. Because this is a very certain thing. It wouldn't make sense to say that there's a possibility of it being equal because we have all of the numbers. Now, similarly, there is the less than equal to symbols and there's the less than symbol. This is for where the number on the right-hand side this time is greater than the number on the left-hand side. And this is applied for the same for the less than equal to symbol, except the less than equal to symbol has the opportunity to make both sides equal. We'll be looking at this further in later examples as well. So, how do we illustrate inequalities with a number line? Now, often we're not going to get inequalities alone. We won't just be getting, oh, x is greater than 5 or x is less than equal to -6. Often we'll be also getting an equation that we need to simplify first before we can boil it down to these kinds of simpler inequalities here. And we'll be looking at that through these two examples over here. Let's start with the first one. In our first one, we have x plus 2 is greater than -5. Now, in this case scenario, we first need to simplify this as we would our regular equations. So right now we can apply the same rules. We want to cancel out the 2 on this side of the equation and instead bring it to the other side. We can do that by subtracting the whole equation by 2 as we normally would. That would bring 2 to the other side without changing this symbol over here. It would make the expression x is greater than -5 minus 2, which if you were to simplify it further, you would get x is greater than -7. With that, let's just draw the number line really quickly. Alright, so over here, I'm just taking it from 10 to 0 because we have to make our number lines most appropriate to the kind of range that we're being given. Right now, first let's look at the symbol we have. Let's look at the number we have first. Right now, we have the number -7 over here. That means we need to draw a dot over -7. I'm going to keep that dot empty for now, because as you can see, this is not an equal to symbol. This is just a greater than symbol. There's no greater than equal to or lesser than equal to. It's just a greater symbol. So we will be keeping this circle over here empty. Now we also have to look at that this x value has to be greater than -7. This means it has to cover the range of values above that, and so we need to draw our line continuing after -7 because that is the solution for this inequality over here. It won't be exactly like that we will have a definite answer for x. Instead, it's going to be an indefinite answer because we're only being given a domain or a range right now. Let's continue to this example here. Minus 8x is less than 16, though for the sake of learning a new concept, I'm just going to write minus 8x is lesser than equal to 16. We'll be running with that question instead. Now for this equation, we can now see that we need to use a multiplication, a division operator to cancel out this minus 8 over here. However, there's something peculiar that happens whenever we do that. Let's first divide minus 8 with the whole expression that we have. This will cancel out this minus 8 over here because this is division, and right now minus 8 is being multiplied into x. This will cause x, and I'm just going to leave out this inequality symbol right now. We know that 16 divided by minus 8 will be minus 2. Now here's what happens when we divide the whole equation by a negative number. When we do that, the sign will actually flip. Now this only works when we're dividing or multiplying with a negative number. That's the only case in which this inequality symbol will flip around. This will not happen in the instance of addition or subtraction. Now this will give our final inequality of x is greater than equal to minus 2. And with that, I'm going to be drawing our number line according to that. Alright, now that we have our number line, this is the range I'm going to be using because I feel that is most appropriate for this situation. Now first let's keep in mind that we have minus 2 over here. That means that we have to create a little circle over here. And this is aligning with the minus 2 number over here, so we have to keep that in mind. Next, let's look at our symbol here, which is greater than equal to. Because we have this greater than equal to line over here, this means that x can be equal to minus 2. It's just that it's very ambiguous right now. So that's why it would make sense to have the greater than equal to symbol in this case scenario. Because this is a greater than equal to symbol and it has the possibility of being equal to 2, we have to include minus 2 in our answer and circle in this circle over here. Now, let me just write this again. We have the equation x is greater than equal to 2, and now that we know that our circle is shaded over here, we now have to consider which side the line has to go to. Because x is greater than equal to 2, the range of answers encompassed will be toward the positive side because x can be more than minus 2. This means that we have to draw our line over here like this. In fact, it's better to actually add these arrows over here. Now, there's one more way to write this notation. This is one way you can absolutely illustrate these number lines, and I don't think anyone will really mark you incorrectly for that, but there is also another notation to keep in mind. Now, this is the bracket notation. Now, one side is where you can use this bracket over here to mention a greater or less than equal to symbol. Over here, we have this greater than equal to symbol, and because it starts from minus 7, we can actually use this bracket over here, and we can say it's not equal to minus 7, but it can be more than that. And then from there, we can just add this line over here and add this arrow at the end to show that it's an infinite range. This could be also written as minus 7, comma, infinity, because this will keep going for infinity. However, when we have a greater than equal to symbol or something similar to that, we have to use our square brackets over here. We can actually also just use our square bracket over here. Now, because we have a greater than equal to symbol here, we have to use a square bracket because that means that it's essentially saying, yes, our answer can be equal to minus 2. From there, you just have to go on with an arrow over here, and that will show this kind of function over here, minus 2 to infinity. Now, this part is a little bit more complicated, so we'll be going into more depth during future lessons when we're considering inequalities again. However, for now, we're done with this lesson, and here are the sources.